Now, we treat scenario 5 where we have x squared minus c. What has happened here is that this happens where b is equal to 0. Remember that we started by saying that x squared minus bx minus c. That's what we're working with. Or this could also be plus, this could also be plus, this could also be plus. But in this setup, b is equal to 0. And if b is equal to 0, it means that everything here is eliminated. And you're going to have x minus c. Now, but under this scenario, we assume c as a perfect square. We assume what? C as a perfect square. So what we may likely have is something like x squared minus a squared, where c is equal to a squared. X squared minus a squared. So when you see this, the expression above, the expression above is called the difference of two squares. The expression above, where you have x squared minus a squared, is called what? The difference of two squares. And as a student of grade 9, it's very important that you should be able to identify this in questions and spend less than 10 seconds doing this. If you're spending up to 20 seconds doing this, then there's something fundamentally wrong with your assimilation of this idea. So you must see it, recognize it, and in less than 10 seconds or 15 or 20, worst case, you have this the question wrapped out. So we're going to take 2 questions under this and see how we handle this. An important skill you must develop in your mathematics is to be able to handle what is called the idea of trial and error. Trial and error. You should be able to look at concepts and be able to tell, okay, if I try this, will it work? Now, x squared minus a squared is going to give you this. If I expand this, I'm going to get this. So take note of this. So if that is understood, your next line here should be what? X squared. This is a perfect square. 49 is a perfect square and will require us saying, alright, so this will be x squared. 49 is what? 7 multiplied twice. So that will be 7 squared. So this will simply be equal to add x to 7 and subtract 7 from x. So that's what it is. So then you need to think too much. If you go in that same order, let's look at what we have in question 18. In question 18, we have x squared minus 4. Step 1, this is a perfect square, so that will be x squared minus what? 2 squared. What does that mean? Add 2 to x and remove 2 from x. That's all. So you see that these are questions you should not spend more than 15 seconds solving. If you spend more than that, something is wrong. Okay, we continue with our concept of our scenario 5 by digging deeper into the matter of difference of two squares. By digging deeper into the matter of difference of two squares. If you look at your textbook exercise 9J of the New General Mathematics for Js3, page 94, you discover that there are more expanded questions testing this concept of difference of two squares. When you have x squared minus a squared, what it simply means is that add the terms and do what? Add them, subtract them, and finally do what? Multiply them. Now if you look at number 1 is quite straightforward. X squared minus 1. This will be what? X squared minus 1 squared, which will be x minus 1 into x plus 1. That's very straightforward. Now let's look at question number 2. 1 minus y squared. That will be what? 1 squared minus y squared, which invariably will be equal to 1 minus y into 1 plus y. That one is also very straightforward. But when we go to from question 3, 4 upwards, we may need to do a little tweaking to our definition to be able to handle those ones. So let's try a few of those questions now. Now let's look at the next scenario. 4m squared minus n squared. You will notice that to this term, there's something unique here. There's a 4. So how do you solve this? 4 is also a perfect square. So I'll write 2. 2 squared is what will give me 4. This will be 2 squared m squared minus what? N squared. This one is multiplied twice. This one is multiplied twice. So it means that I can have it that this together is multiplied twice. Minus n squared. Now, some of us might still find it a little difficult to understand that. Now look at 2 squared m squared is the same thing as 2 times 2 times m times n. We can regroup them. We can do what? Regroup them. I can group this with this and group this with this. What am I going to have? 2m times 2m. How many times is 2m occurring? 2m or bracket 2. So that's the idea we have here. It is at this point we can now apply our difference of two squares. We can now say 2m plus n added and then 2m minus n. And this will be your final answer. Alright. Okay, so in question 4, you discover that where we have the problem is with this 16. So this will be what? U squared minus, what's this? 16 is a perfect square, so that will be 4 squared v squared. So the next thing you do is to say u squared minus 4v all raised to the power of 2 based on the understanding we've gathered previously. And this will mean that I will add u to 4v and multiply it by subtracting 4v from u. That's all. As simple as that. More often than not, when students are giving questions, 5c squared minus 45d squared. When you're giving questions, some students will simply look at the question and say it's not possible because you have narrowed yourself to just the concept. Remember that when we give you a question, more often than not, we try to test previous knowledge to see how well you're able to pull from previous learning experience to what you're learning now. If you remember your concept of factorization, you discover that 5 is a common factor to these two. So to solve this, you need to factor 5 out first. And you left to c squared minus 9d squared. And these are the kind of questions I love to set in an exam. This will now be equal to 5. This will be c squared. I now treat 9. That will be 3 squared. And what? D squared. What do I have? This will be 5 into c squared minus 3d all squared all bracket close. So what's the next thing you do at this point? This will simply be what? 5 into c plus 3d and then c minus 3d. So what may look like a very difficult question has all been very easy all along. So you must, when you see a question, don't freak out. Calm down, look at it. Draw from all the topics you have covered. Is there anything I have learned that can help me out here? Discover that if you don't remember your factorization, you may not be able to cross from here to here. Alright, so that's just one off the board question. And I think with that, we'll be calling our class of factorization a very awesome one. And we'll continue with this. This is part 6 of it. And we will continue. Factorization will continue shortly. Don't go away.